Good morning. Today I'm going to discuss BCD counter, which is an example for an asynchronous counter. This is an example of asynchronous counter. BCD means binary coded decimal. That means a binary coded decimal means decimal numbers are called as bits. That means it is from 0000 to 1001. That means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and after that again coming back to 0. That means counting means 0 to 9, then 0 to 9, 0 to 9, etc. That means BCD counter, binary coded decimal counter. That means here using an asynchronous counter or using a BCD 16-bit counter. That means 2 raised to 4 modulo asynchronous counter can be used for counting 0, 0, 0 to 1, 1, 1, 1. But here in this case you have to stop at 1001 and then you have to go back to 0. That means afterwards if it is operating normally, what will happen after 1001, this will become 1010, then 1011, etc, etc. But here in this case, after 9, you have to reset it back to 0000. For that, what we have to do? So here I am introducing two more pins for a flip flop. Here for a flip flop, you have two more pins. This is preset and clear. Preset and clear. These are two active low pins. Means these are active low. That is why we have two circles here. That means that is active low. That means this will act when preset is equal to 0. And this is also active low means this will be active when clear equal to 0. Okay, that means the normal operation of a flip flop can be overdone. That means usually the next q value depends on current value of t and current value of q. That means depending on the value of t and depending on the value of q, the next value will be set or reset. Usually here this is a T flip flop, and for this T flip flop the normal operation of this flip flop can be overridden using preset pin as well as clear pin. Once you have the if you preset, if preset is equal to 0, what will happen? This q will be set to 1. That means once you have preset is equal to 0, that means this is an active low signal, and when preset is equal to 0, what will happen? Automatically q will be set. The value of q will be set, and if clear is equal to 0, if you are purposefully or intentionally make clear equal to 0, what will happen? This is an active low signal. That means q equal to 0. That means you can either set q is equal to 1 or reset. That means setting as well as resetting pins by overriding the normal operation of a flip flop can be done using preset as well as clear signals. Okay, that is the preset and clear signals. Now then how a BCD counter can be designed using 4 flip flops. Here this is Q0, Q1, Q2 and Q3. This is Q3, Q2, Q1, Q0, and as we have already discussed in asynchronous counters, here this is actually Q0 and that output is given as the input to the next flip flop, and the output of that is fed to the next flip flop, and the output of that is fed to the next input, and this is the most significant bit, or Q3 is the most significant bit and Q0 is the least significant bit, and this is a T flip flop, and here you are going to have clock signal. This is not T, This is actually clock, and this is a negative edge triggered flip flop. Negative edge triggered flip flop can be used for designing up counters, asynchronous up counters. So initially, this will be set 0 0 0 0. That means here Q3 equal to 0, Q2, Q1 and Q0 are zeros. 0 0 0 0. And when this clock pulses on the trailing edge of the clock pulse, that means this is the clock and this is the trailing edge of the clock pulse, and this is a negative edge triggered flip flop, and then what will happen? The state of this Q0 is changing, and that is why you have 0 0 0 1. And after that, the normal operation of a synchronous counter that you already know. Then what is the change? What change you have to do? That means what are the modifications you have to do to convert an up counter to a BCD counter? So if you are operating normally, what will happen? This will count 0 0 0 0 0 1 etc. 1 0 0 1 1 0 1 0 1 0 1 1 etc. up to 1 1 1 1, and after that again coming back to 0 0 0 0. So that is the normal operation of a an asynchronous up counter. And now I am going to have a circuit here. That means when the current input is 1001, that means here the value of Q3 equal to 1, Q0 equal to 1. That means after this, the next automatically, if this is an asynchronous up counter, automatically the next signal generated will be 1 0 1 0. That means after 1 0 0 1, the next output generated will be 1 0 1 1. So when this happens, what you have to intentionally make or intentionally clear all the flip flops. Okay, that means as this is an up counter, 0 0 0, this starting from 0 0 0 0 to 0 0 0 1 etc. up to 1 0 0 1, and normally after 1 0 0 1 it will generate 1 0 1 0, but 1 0 1 0 is actually it is not a valid BCD number. So if this is the input, what you have to do? You have to clear all the flip flops so that all the values should be, you have to make it 0 0 0 0. That means if you have 1 0 1 0 as Q3, Q2, Q1 and Q0. Suppose that the values of Q3, Q2, Q1 and Q0 are 1 0 1 0. Then what you have to do? You have to clear all the flip flops so that the next value will be, that means you have to, using this clear input, you have to make it what? 0 0 0 0. So for that I am going to have a combination circuit. That means I am going to have a NAND gate, and the NAND inputs are Q3, Q2, Q1 and Q2. That means Q3 equal to 1. That means you are going to give Q3 as such. Q2 is, that means Q2, suppose that this is Q2, then you have to negate it and give Q1 as such you are going to give, and Q0 also you are going to complement it and give. That means now if all of them are ones, this is an AND gate and the output will be 0 here. That means the Q3, Q2, Q1 and Q0 are fed to this circuit as this is a circuit, and Q3, Q2, Q1 and Q2 are fed to the input, and if the output is 0, that means if the output is 0, that is you are going to give us clear signal. That means you are taking this Q3, Q2, Q1 and Q0 from here, Q3 from here, Q2 from here, Q1 from here and Q0 from here. Once you have 1 0 1 0 as the values of Q3, Q2, Q1 and Q0, those are fed to this circuit, and if all of them are ones, that means if Q3, Q2, Q1, Q0 is 1 0 1 0, what will happen? The output will be 0. That means if all of them are ones, then taking the negative, this will be 0, and as this is an active low signal, all the flip-flops are cleared, and now this condition is reached. Okay, so then afterwards it will continue like this. That means 0 0 0 0 to 0 1 0 0 1, and after that 1 0 0 1, when 1 0 1 0 is the output of Q3, Q2, Q1, Q0, then using this combination circuit, you are going to clear all the flip-flops, and then the status will be 0 0 0 0, and again the counting. It is counting like this, and after 1 0 0 1, again it is coming back to 0 0 0 0, etc. etc. So that is the operation of an asynchronous BCD counter. So suppose that a simple variation for this is, suppose that instead of having Q3, Q2, 0 0 0 0 to 0 1 0 0 1, that means instead of counting 0 to 9, suppose that you are going to count 2 to 9. That means starting point is 2 and ending is 9. That means after 9 it is coming back to 2, 2 3 4 5 6 7 8 9, then coming back to 2 3 4 5 6 8 9, 2 3 4 5 6 8 9, etc. etc. That means after 9 you have to reset this to 2. It is not 0. For that, what you have to do? That means 2. You are going to count 2 to 9. 2 to 9 you are going to count, and say there is a minor modification for this circuit. I am not going to have this. Instead, clear signal has to be given to some of the inputs. That means once you have 1 0 1 0 in as the output of these flip-flops, instead of resetting this back to 0 0 0 0, you have to, that means once I am going to have a 2 to 9 counter, and it is starting from 2 and ending at 9, then coming back to 2. That means initially we are having 0 0 1 0. That means you are starting your count from 0 0 1 0 and 0 0 1 0. Then you are counting up to 1 0 0 1, and after that, if 1 0 1 0 is the output of Q3, Q2, Q1, Q0, you have to reset this back to 0 0 1 0, not 0 0 0 0. For that, here preset pin 4, that means this is Q3, Q2, Q1, Q0, Q3, Q2, Q1, Q0. Here this has to be the preset signal of this, or here I am going to have, this is Q1 and this signal has to be active. That means this is an active low signal and this has to be activated using some combination circuit, and all other pins have to be cleared. For that, what you have to do is, here if it is 1 0 1 0, this is 1 0 1 0, then this is active low. Now I am going to clear using this signal. I am going to clear this. That means 0 0 1 0 I want. So Q0 has to be 0, Q1 has to be 1. I am not going to give any, I am going to have this has to be, I have to clear, and this one also I have to clear. That means clear signal has to be given to three flip flops. That means Q0, Q2 and Q3, and this pin or this Q1 has to be set. So what is Q1? That means another signal which is going to this location, so that will be set. That means once you have this 1 0 1 0 1 0 1 0, you have to set it back to 0 0 1 0. What you have to do is, this is the normal one. That means you have cleared Q0, Q2 and Q3. Q0, Q2 and Q3, and you have preset. That means you're going to set this pin. That means Q1 pin. But if you look at this more carefully, here you have 1 0 1 0 and here you have 0 0 1 0. So actually you need to reset this pin only. You have to reset this pin only. So in that case, this Q3 has to be reset. So there is no need to have these signals. Instead, you have to clear this only, and there is no need to have this also. But generally speaking, you have to use preset pins as well as clear pins for accomplishing this task. So suppose that if you want to have a 2 3 4 counter, 2 3 4 counter, that means 2 3 4 2 3 4 2 3 4 etc etc. So for 2 3 and 4 you generally 3 flip flops, and after 4, when 1 0 1 5 is coming, 5 is the output. We have to set this as 2, that means 0 1 0. So accordingly you have to design those circuits and do that as an exercise, and that is all about a BCD counter. That means a BCD counter is starting from 0 0 0 to 1 0 0 1, and after that, when it is after that, it will increment the value to 1 0 1 0, and when 1 0 1 0 is the output of Q3 Q2 Q1 Q0, then what will happen? It will clear all the flip flops. So you should always remember these preset and clear signals. Okay, and with that, the discussion of asynchronous counters are over. Thank you.